Welcome to the 2021 University of Wisconsin-Madison Virtual 3-Minute Thesis Finals. I'm William J. Karpus, Dean of the Graduate School, and it is my honor to welcome everyone to this exciting event. Today I will be joined by my co-host, Samantha Knott, NSF Fellow and Chemical Biology PhD candidate here at the University of Wisconsin-Madison. Sam has served as a 3MT coordinator for the UW-Madison chapter of Graduate Women in Science for the past 3 years.
Hello, everyone. I am also so pleased to be here tonight and am excited to be a part of the first ever UW-Madison Virtual 3MT Finals. Today, we look forward to watching the videos from our top 9 3MT finalists, announcing our top 3 winners, and voting on the People's Choice Award. Before we get started, I would like to share that live closed captioning service is available for this event and can be accessed through the link in the description of this video and through the URL that is currently displaying on your screen.
As many of you know, 3-Minute Thesis is an international research communication competition started at the University of Queensland in Australia over a decade ago. The idea for 3MT was born during an Australian drought when people were encouraged to use egg timers to conserve water while showering. The 3-minute timer, along with a passion for effective and concise science communication, gave the University of Queensland's Dean of Graduate Studies the idea for the competition.
Wow, that is interesting. The competition has evolved a lot since its creation, particularly this year when COVID-19 caused 3MT competitors to go virtual all over the world. Even though the format has been adjusted this year, judges will still focus on the same criteria of comprehension, content, communication, and engagement. As the title of the competition suggests, competitors must keep their talks under 3 minutes, and they are permitted to use only a single static PowerPoint slide as a visual aid. 3MT competitors must also communicate in language that is appropriate for a non-specialist audience. This means avoiding jargon and technical terms, which is much easier said than done with these complex and specialized research topics.
This year's competition began in September 2020 with over 60 competitors vying for a chance to compete. 39 talented UW-Madison graduate students advanced to the semifinals in November. Their presentations were stellar and the competition was extremely close, and 9 competitors were selected by a panel of our judges to advance to the final round. Thank you to all the 39 competitors who participated in the 3MT semifinals in November.
Now, I'd like to take a minute to thank everybody who helped to put on this event. And first of all, thank you to our sponsors. This would not be possible without them. Gilson, ProMega, and Science is Fun funded the prizes for our competitors. We will also be hearing from Bassam Shagashiri of Science is Fun and the Wisconsin Institute for Science Literacy later in this broadcast.
And thank you to our partners at the Writing Center and Design Lab, who helped create content and deliver workshops to support our 3M. Also, thanks to the Graduate School Office of Professional Development and Communications and Graduate Women in Science for all of the great administrative support.
We also want to recognize our 9 semifinalist judges who volunteered their time to help select our finalists.
For the final round of competition, our first judge is Eric Hamilton, science writer for University Communications here at UW-Madison. Thanks, Eric.
We'd also like to thank Elena Shu, degree coordinator from the UW-Madison Graduate School, for serving as a judge for the finals.
Finally, we'd like to recognize our third finals judge, Ann-Lynn Gillian-Daniel, director of the Integrated Education Group and the Materials Research Science and Engineering Center. Thank you for all of your work as judges for this year's 3MT competition. I know it was no easy task to pick a winner from this group of top-notch communicators.
And finally, a big thank you to everyone who is joining us today on the webcast. You as viewers also have a role in this competition, as you can vote to select the People's Choice Award winner. You can visit the link at the bottom of your screen to vote for the People's Choice Award. Voting went live today, and it will end 5 minutes after the last 3MT video is played this evening.
All right, folks, the time has arrived for us to watch our first round of 3MT videos. Then we will take a few minutes to meet each of these accomplished graduate student researchers.
What do Muhammad Ali and Michael J. Fox have in common? Well, besides being famous, both were diagnosed with Parkinson's disease. Parkinson's is a progressive neurodegenerative disease characterized by motor symptoms like tremors or slowness of movement. In less than 10 years, more than 1 million people living in the United States will have Parkinson's. This means it is more likely that you will know someone with this disease, and even more important that we ensure the best care for them. One way of doing so is by promoting activities that help maintain the quality of life of the person with Parkinson's. One such example is physical activity. Physical activity, as we may know through personal experience, is highly influenced by the people around us. In this case, care partners. Care partners are usually family members or spouses that help with a multitude of responsibilities like bathing, cooking, and keeping the person with Parkinson's active. However, care partners may face several obstacles when promoting physical activity, may not engage in physical activity themselves, and may even report worse health outcomes than the person they care for. Yet, physical activity researchers barely include care partners. This must change. So I am proposing a 4-month physical activity intervention for people with Parkinson's and their care partners, examining stress, physical health, and daily physical activity. Before and after the intervention, we will take saliva samples of cortisol, a type of stress hormone, do physical assessments on factors like strength and balance, have participants wear activity monitors like Fitbits, and do interviews to understand their experience. Participants will be randomized into 3 groups, one where they are active together, one where the care partner is not included, and a control group to compare our results. Each month, participants will do workshops on different types of physical activities like dance, boxing, tai chi, and aquatics. The group that includes the care partners will also learn strategies on how to do and promote activity for themselves. And in between workshops, we will call and text to keep people motivated and moving. At the end of the 4 months, the control group will also have a chance to do the program. Now, we hypothesize that the group that is active together will have greater reductions in stress, greater improvements in physical health, and engage in more daily physical activity. We believe that by care partners promoting physical activity for the person with Parkinson's and for themselves, that both parties will benefit. We believe that we are better when we move together, and we cannot wait to see what the research tells us.
Approximately 38 million people worldwide are infected with HIV, human immunodeficiency virus. There is currently no effective vaccine or cure. HIV infects cells of the immune system, and the dynamics between HIV and the immune system are much like hide and seek. HIV hides, and the job of the immune system is to seek and also destroy. But HIV is a formidable opponent. It integrates its genome into host DNA, where it can conceal itself silently and indefinitely. And HIV avoids immune destruction in 3 major ways. First, HIV mutates rapidly, changing itself to be unrecognizable to immune cells. Second, HIV hides in the lymph nodes, which are places not all immune cells have access to. And third, because there is no cure, eventually the immune system becomes exhausted. So imagine, you're playing hide and seek and you're the seeker, but you don't even recognize who you're looking for. And they're hiding behind a locked door you don't have the key to open. And the game lasts for decades straight with no break. I imagine you'd be tired too. So what can we do to help the immune system? Some antiviral drugs called ART can suppress HIV to undetectable levels. This means instead of seeking 1 million hiders, maybe you only have to find 12. But ART must be taken every day, and if ART is discontinued, HIV populations recover, and the disease may progress to AIDS, which essentially means the immune system has lost. I use a virus called SIV to model HIV infection in macaque monkeys, and I am testing a novel therapeutic strategy. The ultimate goal of my research is to enable the immune system to control SIV replication without the need of lifelong ART. I am treating SIV-positive monkeys with both vaccines and immunotherapy to help the immune system combat HIV's 3 immune evasion strategies. First, the vaccines present small portions of a protein in SIV to the immune cells so they can recognize the virus and destroy it quicker. This is like telling the immune cells they're searching for a virus wearing a yellow sweater. It wouldn't matter if the virus put on a disguise because the immune cells still know they're looking for a yellow sweater. Second, the immunotherapy gives immune cells access to the locked door of the lymph nodes where HIV is hiding. And third, the immunotherapy gives the immune system a boost, like a shot of espresso, so there are more immune cells that can seek and destroy better. If successful, this would be termed a functional cure, meaning that while HIV continues to hide, the immune system wins, without the help of ART. A functional cure would benefit people living with HIV, particularly those who might not have access to ART, allowing them to live in HIV remission.
Picture this. You just moved to a new city. Over time, you get to know the neighborhood like the back of your hand. You see this building, you know you're on that street. You see this bridge, you know you're near that park. The point is, visual cues are helping you learn where things are. It's the same with students learning science or math. They have to learn abstract concepts they cannot see, like chemistry molecules. Research shows that using visuals can help more than verbal descriptions. You wouldn't describe a molecule in plain English. You would draw it. A picture is worth 1,000 words. In fact, you rely on visuals every day. You see red, you stop. You know you need to charge your phone because of a battery icon. But what about a graph of COVID cases or a map of the US elections? As it gets more complex, how do you get better at learning from visuals? That's what I do. My research helps learners extract information from visuals quickly and effortlessly. This is called visual fluency. Here's how I do that. I developed an online training for chemistry undergraduates where they have to pick the correct molecule from 4 choices. To help them learn, the software gives them 2 types of feedback: correctness feedback or error feedback. The first type, correctness feedback, indicates whether the answer is correct or incorrect, like the first example in the image. You've seen that type of feedback in a Word document. You get red squiggly lines when you type a wrong word. The second type is error feedback. It tells you that the answer is wrong and it shows you the exact location of the error, for example, using a yellow highlight. Which type of feedback do you think is more helpful? Telling me that I'm wrong or telling me where I'm wrong? It turns out that both help, but the one that helps more is not what we expected. Studies have actually shown that your brain needs a workout. It can get very lazy relying on detailed feedback all the time. In my study, both types of feedback increased student learning significantly. But surprisingly, the more detailed error feedback did not improve learning as much as basic correctness feedback. Why could that be? Well, we know that self-directed learning helps students discover by themselves how to fix their errors. So it's a balance. Online trainings need to use feedback, but not so much that it gets in the way of self-directed learning. The next step will be to determine how much feedback is too much. This line of research is especially timely with the increased reliance on online learning during the pandemic and beyond. So now you know, feedback does help students learn, but sometimes less is more.
Now that we have seen the 3MT talks, let's take a few minutes to get to know our first three 3MT finalists a bit more. Joining us tonight, we have Laura Preto, Claudia Ramley, and Olivia Harward. Welcome all.
Okay, let's jump right in and meet our first finalist, Laura Preto, a PhD student in kinesiology. Hi, Laura. It was fascinating to hear about your research. What keeps you motivated as you pursue your graduate degree?
What keeps me motivated is connecting with the community of participants, fellow grad students, and my very motivating advisor, as well as staying curious about how to best provide equitable services that promote health for older adults with disabilities. What also keeps me going is one inevitable truth. We all age. And as we age, it is critical that we have services that promote our quality of life and health. By investing in the health of our older adult community, we are investing in our own futures and the futures of the people we love.
Thank you for sharing about your motivation. Could you please share with our audience what a typical day in a graduate school, in your program especially, looks like for you?
Well, before COVID-19 pandemic, I met with my advisor in lab nearly every morning, and then we would schedule appointments and interviews with research participants and spend time, and in between I would spend time studying or writing for classes. On weekends, we would facilitate physical activity interventions for families of children with autism. This included long nights of coordinating our efforts, preparing data collection materials, and training undergraduate students. After the workshop or a long day scheduling, communicating, interviewing families, we would go back to the lab, drop off the equipment, and newly collect the data and end our days exhausted but happy. Because that's what a physical activity intervention takes. Lots of effort and a great team.
Wow, your dedication and motivation is inspiring. Thank you, Laura, and best of luck for this evening.
Thank you.
Yes, thank you, Laura, and good luck. Next, let's talk with our finalist, Olivia Harward, a PhD student in cellular and molecular pathology. Hello, Olivia.
Hey.
Hi. Could you share with our viewers how you became involved in your current research?
Yeah, my interest in scientific research started with high school science fair projects and grew throughout undergrad. And I started in the cancer realm of research, but I became interested in viruses when I had the opportunity to travel to Antarctica to complete an independent study and do a summer research program that focused on viruses that infect bacteria in the ocean. And I eventually determined that I was more interested in pathogenesis of human diseases than marine microbial ecology, which is how I ended up in the cellular and molecular pathology program here.
Wow, that's very impressive. And I bet Antarctica was very cold. Thanks you for the background, Olivia. So what would you say is the most exciting aspect of your research?
The opportunity to design and run a non-human primate study has been really exciting and also challenging. Some human diseases can be studied in humanized mice, but our lab studies simian immunodeficiency virus, or SIV, in macaque monkeys, which is an excellent preclinical model for HIV. And SIV pathogenesis in macaques is very similar to HIV pathogenesis in humans, which allows us to test novel therapies that may eventually be approved for humans living with HIV. So through designing and running this study, I've gained experience with the clinical and translational aspects of infectious disease research, which has been a great fit for my research interests and has helped prepare me for a future career.
Thank you. It sounds like you've done a lot of impressive work. So thank you for sharing with us your work on infectious diseases.
Yes, thank you, Olivia. Claudia Ramley, you're up next. Claudia is a graduate student in learning sciences. Hello.
Hello.
What motivated you to pursue a graduate degree in learning sciences, especially in the area of educational psychology?
So after spending 10 years in industry where I was a trainer for medical devices, I worked a lot with adult physicians across more than 18 countries. And at the time, my company was going through a major overhaul of their education program. And so I had so many questions about how to really design effective learning tools for adult learners. I wanted to understand the research and be able to develop tools to effectively improve the way adults learn.
Thanks, Claudia. After spending so much time in industry, what is the most exciting aspect of your experience as a graduate student?
So UW-Madison provides so many exciting opportunities to learn and develop, whether through the graduate school, the Writing Center, or the countless conferences for graduates and researchers alike. I think also another exciting aspect of my experience as a graduate student is that I have a great advisor who encourages me, supports my curiosity, and guides me towards resources that will help me grow in the way I think about my research. I also mentor undergraduates, and that keeps me motivated because they contribute so much diversity to the research conversations in the lab.
Well, thank you for bringing your wealth of experience back to UW-Madison and making this a better place for all of us. Thank you again, and I look forward to learning more about your research.
Good to see you, Claudia. It's great to hear about the world-class learning opportunities and advisor support that UW-Madison graduate students receive.
All right, that was great to connect with you, Laura, Olivia, and Claudia. Now we'll move on to the next round of 3MT Talks.
What do you think the future looks like? Are you thinking about the future after grad school, or maybe the future in 30 or 60 years? Well, we physicists tend to think of the very distant future, in billions of years. Sadly, we still don't have a clear picture of how this future could look like, especially after the unexpected discovery that galaxies are flying away from each other faster and faster with time. So, is the universe going to expand forever, or can it ever stop? To answer these questions, we need to understand what is causing the expansion. One popular theory states that this expansion is caused by a strange energy that we call dark energy. Unfortunately, there is a lot that we don't know about dark energy, and hence questions about the evolution of the universe remain unsolved. In my research, I studied dark energy by analyzing systems of double Einstein rings. These are very rare systems composed of a heavy galaxy and two additional galaxies located behind the first one. The presence of the heavy galaxy cools the light of the two other galaxies, and this can be perceived as pieces of two rings in the sky. This approach for studying dark energy couldn't be performed 10 years ago because we didn't have telescopes that could see deep enough in the sky to detect these systems. But now we have them. In addition, for these systems, we can define a variable that depends on the radii of the rings, and this variable is more sensitive to the dark energy nature than other methods. In consequence, by performing a statistical analysis of this variable, we can be more conclusive about the nature of dark energy. To start this analysis, first we need to find double Einstein rings. The plan is to perform a search on the data gathered by the Dark Energy Survey, a census of hundreds of millions of galaxies. Unfortunately, we're looking for a needle in a haystack. Out of 36 million images, we expect only about 20 to have these systems. Luckily, this studio search can be executed by a machine. To do this, we need to create realistic simulations of these systems and use them to train the machine to recognize an image with a double Einstein ring. After this, we can use real images as input for the machine to find real systems. Hopefully, we'll find enough systems to perform a statistical analysis and understand a little more about the nature of dark energy and, in consequence, about the future of the universe.
In Dan Brown's best-selling novel, The Da Vinci Code, we meet Professor Robert Langdon, a religious symbologist who travels the globe deciphering hidden meanings in art, solving the unsolvable riddle, and saving the world, and the arts, just in the nick of time. As a proverbial man of science, Robert Langdon is an exaggerated version of reality. But those of us who study historical images do spend a significant amount of time traveling through library catalogs, vendor databases, and archival materials, looking for images and where they appear throughout history. Unfortunately, these traditional research methods are very time-consuming, leaving only a few opportunities to save the world between research projects. But why do historical images matter? And what can book illustrations tell us about economics, religion, politics, and the spread of information in the past? Well, my research explores these questions at the intersection of book history and visual culture through the images and illustrations that are found in colonial American books. To do this research in a more efficient way, my project is built on the creation of a new data set about book illustrations that brings a unique, data-driven approach to the study of book history in early America. I am compiling, transcribing, and annotating information from print and digital resources related to colonial American book titles, specific printers like Benjamin Franklin, the dates and the locations that images were used in published works, and their iconography, their symbolic themes, and the visual representations that we see in different forms of printed material, such as political cartoons or children's books. As my slide shows, with the compiled data from these resources, I can perform analyses that explore, for example, the evolution of the man of signs, how variations of this image appeared and where they were used in colonial almanacs, and its potential economic or scientific meaning in this context. When it is complete, my data set will allow other researchers to explore American visual culture in broad strokes, or deep dive into specific images or image genres to facilitate new discoveries about evolving forms of text and image-based media. In a more general sense, this data will also give researchers back some of the time that they currently spend looking for this information in disparate resources, time that may be spent thwarting the next evil plot for world domination. So whenever you open a book, pay close attention to all of the visual materials inside. You may find yourself able to decipher a hidden meaning from the past and experience your very own Da Vinci Code moment. Thank you.
Many of us know individuals with Alzheimer's disease who are no longer able to perform everyday tasks or remember their loved ones. Shockingly, Alzheimer's disease is the 6th leading cause of death in the United States. Despite decades of research, however, how it develops is still poorly understood, and current therapies are not effective. My name is Katie Zarbach, and I work in a lab that researches the gut microbiome, meaning the bacteria that live in the intestines. Now, you're probably wondering, what on earth does the gut microbiome have to do with Alzheimer's disease? Well, some of the risk factors for Alzheimer's, like obesity and diabetes, can be directly influenced by the gut microbiome. How do our gut bacteria influence us? They often do so by producing small molecules when they eat our food for energy for themselves. One such small molecule is trimethylamine N oxide, or TMAO. TMAO has been shown to worsen diseases in organs that receive a lot of blood supply, like the heart and the liver. The brain is richly supplied with blood, so we wondered, could TMAO impact Alzheimer's? Looking in humans, we saw that levels of TMAO were elevated in individuals with Alzheimer's, and that these high levels of TMAO correlated with increased signs of Alzheimer's brain damage. But does TMAO directly worsen Alzheimer's? To answer this question, we need to be able to change the levels of TMAO. And this is difficult to do in humans. So we work with mice that are bred to recapitulate much of the brain damage that occurs in Alzheimer's in humans. Using these mice, I am testing TMAO's impact in 2 ways. First, I am giving mice TMAO directly in their drinking water. And second, I am making bacterial communities that can and cannot make TMAO and implanting them into the guts of mice, very special mice, that originally had no bacterial life living inside them. Eventually, I'll take a look at these brains of the mice to see if TMAO worsens Alzheimer's brain damage. I expect to find inflammation and damage to the connections between brain cells. This is important because both of these have been shown to be big contributors to cognitive decline in humans. Uncovering whether TMAO worsens Alzheimer's disease will help us to better understand disease development and provide potential therapeutic targets to prevent or slow the disease, helping our loved ones to be more like the people they have always been.
Well, that was just amazing. I'm constantly inspired by the innovative research being done by University of Wisconsin-Madison graduate students. I'm sure our audience members are as well.
I'm sure they are, Dean Karpus. Moving on to our next group of fantastic communicators, it's my pleasure to introduce Jimena Gonzalez, Jeremy McLaughlin, and Katie Zarbuck. We'll start with Jimena Gonzalez, a graduate student in physics. Jumping right in, what would you say is the most exciting part of your research project?
I find it exciting that the methodology I'm using in my research is novel. As I mentioned in the video, I'm looking for very rare systems, and only up to recent times we have developed tools that can detect these systems. So far, a handful of these systems have been discovered, and even though no one has been actively looking for those systems. So I'm pretty excited about what we could find.
I'm excited too. On the other side of things, what has been your biggest challenge so far in your research?
So after my first year of graduate school, I changed my research area, and this was very challenging at the beginning because I didn't understand most of the group meetings and the seminars, and my research was going slow. To overcome this, I started a notebook where I would have a record of all the new concepts and tools that I had to use. And I even went further with this to include meeting notes and seminar notes. So I also included a record of all my talks and presentations. So sometimes I go back to see how much I have learned and how much I have advanced, and this keeps me motivated.
That's really great to hear. Thank you, Jimena. It's been great getting to know you a little bit more.
Thank you, Jimena. Moving on to our next finalist, we have Jeremy McLaughlin, a PhD student in the Information School. Hello, Jeremy.
Hello.
First off, could you share the most exciting part of your research with our viewers?
Yeah, so first let me just apologize for my audio quality if it's not very good. But to answer your question, for me, it's been really exciting to just bring my passion for historical books and data science together through my project, which is extending into the discipline that falls under the umbrella of digital humanities, merging together digital technologies and traditional humanities research. Compiling this information into a comprehensive data set is somewhat cumbersome and it's taking a really long time, but it's been just fascinating watching the data grow and being able to pull out some initial trends and bits of interesting data points for follow-up down the road.
I'm sure all of that hard work will pay off pretty soon. What have been some of the biggest challenges in your research?
Well, for me, some of the biggest challenges have been in academic distractions, shiny scholarly objects in the forms of new theories or methods that I'm exposed to as a student. So there are just so many interesting and exciting ideas or projects that I'd love to spend time with and learn more about, but I've really just had to learn to avoid this as much as possible. So I keep a spreadsheet of interesting stuff to follow up on, but I've sadly just had to train myself to be strict about where I spend my time, which has helped me keep my focus on specific things related to my project and my PhD studies in general.
Yeah, I'm impressed with your organization and your focus, and it really shows through in your work. Thank you, Jeremy. It's been great getting to know you.
Thank you.
And our last finalist of this round, Katie Zarbuck from Cellular and Molecular Pathology. Hello.
Hi.
Hi. So what would you say is the most exciting part of your research?
Yeah, one of the most exciting parts of my research is actually getting to take a look at the brains of those mice, specifically under the microscope. When I stain for the brain damage that we see in Alzheimer's, I use these really beautiful bright blues and greens and reds and whites, and they're just incredible to look at. There's this one immune cell that I stain for typically in bright fluorescent green, and it has all of these delicate processes that radiate out from the center of the cell. And it's just so magnificent to see them and to watch them go in and out of focus when I change the focus knob on the microscope, and then to actually capture those and turn that into a 3D image that I can then analyze.
Wow, that's fascinating. So what would you say is one challenge that you face with your work?
Yeah, I would say that one challenge that I faced has been being the first individual in my lab to work on Alzheimer's on the mouse side of things. Being a gut microbiome lab, we have great resources for the bacteriology and all of the mouse work we do with those special mice that don't have any gut bacteria living inside them. But in terms of working with the Alzheimer's strains and the brain sections, that was all totally new to us. And so knowing when I needed to put on my graduate student cap and do some novel, independent study design, method design, versus when I was reinventing the wheel was really difficult. And so together with my advisor, we've made some really important collaborations that have really helped with that guidance and training. And then just learning to ask for help early and often, so that I can get the help that I need and study this really cool intersection of the microbiome and Alzheimer's.
Thank you, Jimena, Jeremy, and Katie. It's been great to get to know you a little bit more. Let's get on and learn more about the research in our last set of 3MT talks.
Internet deep dive, Insta-stalking, lurking, creeping, sleuthing, going into Joe mode, a reference to the Netflix show You. These are just a selection of terms that youth use to describe the behavior of looking someone up online. Whether that person be a stranger, an acquaintance, a friend, or a romantic partner, the term stalking has become synonymous with the normative behavior of looking up information about someone online, such as via social media. But what if this stalking goes too far? Now, while social media sites, including Instagram, Snapchat, and TikTok, are appealing to all ages, an astounding 97% of teens use social media, and 81% of teens report that social media makes them feel more connected to their friends. This latter finding highlights a key aspect of the adolescent life stage: peers. Adolescents are practicing social skills that are essential to healthy relationships. They are experiencing for the first time the joys and tribulations of romantic relationships. Ask any teen. These relationships are very important to them, and social media offers another venue to gather information about and interact with peers. So how exactly do adolescents use social media to stalk or learn information about their peers? What if this stalking becomes harmful and resembles cyberstalking? Cyberstalking is the intentional and repeated behavior of stalking someone using technology. The research has largely focused on adults. Adult victims report depression, anxiety, and impairments in work, school, and relationships. But recent studies suggest that 5 to 35% of adolescents experience cyberstalking victimization. Thus, it is imperative to understand how these processes happen among youth, because adolescents are unique from adults and that they are still developing physically, cognitively, and socially. In particular, the part of the brain that controls judgment, decision-making, and impulsivity is not yet fully developed in adolescence. So teens may make mistakes when navigating the social media landscape with their peers. My project seeks to understand and establish how teens label, define, and experience both online information-seeking behaviors, or stalking, and true cyberstalking that occurs on social media. I predict that some behaviors may be essential for practicing social skills, while other behaviors will be perceived as invasive and threatening. I intend to determine what rules teens have for drawing the line between normative and problematic behaviors. Furthermore, I will elucidate the psychological and social impacts that these processes have on adolescents. Relying on teens' perspectives gives them a voice in differentiating between normative and problematic behaviors. Their voices can then inform those working with youth about warning signs to attend to and how to guide teens towards beneficial uses of social media and away from detrimental uses. This ultimately can promote the health and well-being of adolescents, the fundamental goal of my research program. So let's help teens swim when they dive into the internet.
Robot platforms have been used for decades to remotely manipulate the physical world, such as for disaster relief or robot surgery. Historically, these robot systems have been designed with expert users in mind, such as NASA engineers or surgeons who have significant levels of training and domain knowledge. But imagine in 5 to 10 years, when robot platforms are more prevalent, and people could remotely log into these systems to care for a patient quarantined with an infectious disease, or make dinner for an alien loved one. In this future, it will be important to have robot control interfaces that accommodate even novice users without any domain knowledge, and not just experts. To this end, the goal of my PhD work is to create robot arm control interfaces that are broadly usable to afford future use cases such as remote home care or remote healthcare. The primary interface that I have developed to achieve this goal is called mimicry control, where a user demonstrates how a robot arm should move with their own arm motion, and the robot mimics and reflects the user's arm motion in real time. Our goal through this interface is to leverage people's innate manipulation abilities without requiring any understanding of the underlying complexities of robotics, such as kinematics and coordinate frames. My work that investigates this area progresses in 4 high-level steps. First, we highlight a new objective that we want to achieve in our interface, such as affording coordinated two-handed manipulations or preventing collisions with the environment. Second, we formulate robot motion and control algorithms designed to achieve the new objective at hand. Third, we implement our new algorithms on real robots in our lab space. And fourth, we compare our new interface to other existing interfaces by running human subject studies with dozens of real novice users in our lab. In these studies, participants perform simulated home care and healthcare tasks with the robot, and we use objective metrics such as task completion time, as well as subjective metrics such as ease of use questionnaire data, to statistically discern any differences between the interface options being investigated. Through many iterations of this experimental process, we have shown that mimicry control leads to faster performance times, more positive subjective scale outcomes, and requires substantially less training time compared to other available interfaces. In fact, in most cases, people can walk up and effectively use our interface with little to no training, even if they have never seen a real robot before. Going forward, my hope is that my PhD work will lead to emerging technologies that will allow many people to reach out and give a helping hand, even a robotic hand, from anywhere in the world.
It's not a secret. We live in a world where everything seems controversial, and everything controversial, well, makes most of us feel uncomfortable. That's because most of us lack the tools we need to navigate through that tension that exists between differing perspectives. As a result, we're left with a world where our voice has to be louder, stronger, more important than anybody that thinks differently than ourselves. But a person that's only focused on being right and being heard might miss valuable insight from an alternative perspective that, frankly, they might not have been listening for in the first place. Additionally, we know that a person's ability and power to speak up in a discussion might differ depending on their race, their socioeconomic status, or their sexual orientation. This is a huge problem if you want to live in a democracy, because a democracy is enriched through that exchange of different perspectives, especially different perspectives on social issues. So as a teacher, how do I get students to listen? And how do I get students to speak up in difficult conversations? My research turns to art as a solution. You see, art integration is rooted in considering the artist's perspective, analyzing the world through a holistic lens, and encouraging empathetic social engagement. In other words, students are asked to think, research, and reflect on their own opinion before they create something that represents their voice, and then interact with something that represents the voices of others. This brings us to the picture on the screen. What you're looking at is a piece of artwork created by a student named Marco in Miss Moxley's 12th grade art class that was created during a unit that explored the roots of racism in their community. You see, for my study, I looked at teachers and students like Marco as they used art as a form of dialogue to engage with social issues, examine issues of power, establish a point of view, and engage with alternative perspectives. Students like Marco researched different perspectives, established their own point of view, and then created a visual like the one you see that represented their voice and opinion. Data showed that for Marco and his classmates, art served as a way for students to individually and collaboratively construct and contextualize social issues in their community. For Marco in particular, we looked at the ways that he deconstructed issues of power in his community and how those power structures forcibly silence Indigenous populations. In his drawing, Marco made the decision to sew the Indigenous woman's mouth shut as he came to the conclusion that he needed to represent art in a way that showed that the woman was forced to be silent and that the choice was not her own. Data also revealed that art served a crucial push for students as it served as a talking piece and a starting point to have some of these difficult conversations in the classroom. In Ms. Moxley's case, art was more than just a starting point. It was the dialogue itself through which students were communicating. This is important research because if we can teach students how to interact and engage with social issues through their artwork, then we can teach students how to interact and engage with social issues in their democracy. Thank you.
Wow, another engaging and educational set of 3MT talks. If you have not already voted for your People's Choice favorite, polls close in about 5 minutes at 6:52 p.m. Central Time. So vote now.
Well, our audience is getting the last minute votes in for the People's Choice Award. Let's get to know the fantastic competitors who we just saw. It's my honor to introduce Chelsea Olson, Lauren Bagwell, and Danielle Rakita.
We'll start with Chelsea Olson, a PhD student in educational psychology. Chelsea, could you tell us what motivated you to pursue a PhD?
Yes. So I'm obsessed with learning. I graduated with a BA in psychology from UW-Madison, and I couldn't get enough of my psychology courses. I simply wasn't done learning. I took a gap year after my undergrad and couldn't wait to enter grad school. My passion and commitment to lifelong learning keeps me motivated even when research is hard. And I also wanted to help people. My research centers on online aggression in adolescents. Online aggression has countless negative impacts on adolescents' mental and physical health. And so my ultimate goal is to help reduce the rates of online aggression and by extension, improve the well-being of adolescents.
Following up on that, now that you are conducting research, what aspect of your work do you find to be the most exciting?
To me, an exciting aspect of my dissertation is that I will be using semi-structured interviews with adolescents to learn about online information-seeking behaviors and stalking on social media. I'm excited to interact directly with adolescents and learn from them in a more personal manner, gaining information from their direct words. Adolescents, in my opinion, are an incredibly interesting and fun population, and continuing my work with them is exciting in and of itself, and I'm looking forward to developing skills related to qualitative research methods.
I'm impressed with your commitment to lifelong learning and certainly your commitment also to research innovation. Thanks, Chelsea. It's been illuminating to learn about your research.
Yes, thank you, Chelsea. Next, we'll be hearing from Danielle Rakita, a PhD student in computer science. Hello, Danielle.
Hi, Sam.
Danielle, could you please share what motivates and excites you about your particular research at UW-Madison?
Yeah, for sure. I'm incredibly excited and motivated by the fact that our research has the potential to help a large number of people in the future. I think affording many people with the ability to intuitively and comprehensively control robot platforms to manipulate remote environments will drastically improve the way people are able to care for and help others, such as through remote home care or remote health care.
Yeah, that is very impressive. Thank you, Danielle. Is there anything else you'd like to share with us about what's surprising or unexpected about your research?
Yeah, I think one of the most unexpected and surprising aspects of robotics research in general is just how hard the problems of sensing, motion planning, and manipulation are from a computational perspective, and frankly, how far we are from having generalizable solutions for these problems. I think it's a common misconception outside of the field of robotics that robots are going to take over soon, an opinion maybe popularized by movies or books over the years. But the reality is researchers in the area are really just taking baby steps and incrementally figuring out problems or solutions to many fundamental problems because I feel like because people find it so easy to sense and manipulate the world around them, such as seeing a cup of coffee on the table, picking it up, bringing the cup to their mouth and taking a sip, I think it's easy to forget how many difficult subproblems are involved in these seemingly simple actions and how challenging it could be trying to formulate solutions to these problems from the ground up.
That's really interesting. Thanks for sharing, Daniel.
Now let's hear from our last finalist, Lauren Bagwell, who is a doctoral student in the Department of Curriculum and Instruction. Lauren, is there anything surprising or unexpected about your research?
I was surprised by how much transcribing interviews made me smile. Going into the dissertation process, a lot of people went on and on about how that would be a really strenuous part of the process. But I found that as I was going in and getting closer with the data, it was a really unique experience to get to see, the firsthand accounts, the perspectives, the experiences of all these individuals that were part of this 6-month journey with me. And to see the student perspectives and how insightful and vulnerable they were throughout this whole process was a really encouraging thing.
That's wonderful, Lauren. Thanks for sharing. Is there anything else about being a graduate student that you would like to share?
I love grad school because everybody's a nerd. You're going to see, we saw it tonight. Everybody has something that is totally different from the other. Everybody has their own niche and thing that makes them excited to get out of bed in the morning. I enjoy getting to go to class with people that are in the field of education that can push me within my own department. And then getting to be a part of things like where you're getting to learn about things that you've never heard before.
Yeah, your ability to see the bigger picture, I think, is going to serve you well as you continue on as a graduate student and even beyond. So thank you, Chelsea, Daniel, Lauren, for your candor. It's been great learning more about you and your research.
Yes, thank you. So while we're waiting for the final tally, we now have a video that is guaranteed to put a smile on your face.
They asked us to share about our setup for our filming, and here's the deal. I made the mistake of deciding to go and do homework at my parents' house today, not thinking about the fact that I would be filming my 3-minute thesis video in a place that has no good spot to film. And so I had to get a little bit crafty. So we have a map that was on this wall, but we said, bye-bye map, hello blank wall. And then I got this really nifty thing called a kitchen chair. And this is where we get really crafty. So you put the computer on the kitchen chair, you angle your computer so that you can't see all the other objects around you. And then I'm kneeling and talking and it looks kind of normal.
Oops, filming wrong direction. Take 2.
The ultimate goal of my research is, you should know that one.
What do you think the future looks like? Are you thinking about the future?
Analyzing the world through a holistic lens, exchanging and engaging in an empathetic way, and having something that I don't even remember.
This approach for studying dark energy couldn't be performed more than 10 years ago because we didn't have.
Besides being famous, both were diagnosed with Parkinson's disease. Parkinson's is a progressive neurodegenerative. Right. This must change. So I am proposing a 4-month physical activity intervention examining stress, physical activity. I'm sorry.
To answer this question, we need to be able to control the levels of TMIO.
Oy. Oh no, it's recording. Listening for in the first place.
So we can learn how and why they do or do not do physical activity. I can't.
People's Choice Award voting has now ended, and we are just a few minutes away from the announcement of winners. Prior to that, we have words of support from Professor Bassam Shakashiri from Science is Fun and the Wisconsin Institute for Science Literacy.
I'm Bassam Shakashiri in the chemistry department. I congratulate you for your scholarly work. It's so important for all of us as we do our research to satisfy our curiosity and to advance knowledge. It's so important that we share what we have accomplished with others. And that's what this 3-minute competition is about. I congratulate you for being part of this. And I invite you to write a chapter in your thesis, in your PhD thesis, explaining the joy and the accomplishments of what you have done with the public at large. It's so critical for us to advance knowledge and to serve society. But I'd like to show you an experiment. What I have here is a card with 2 arrows, and I have a glass of water. And what I'm going to do is bring the arrows like so. And we just experienced an illusion. And what we want to do is share the real joy of our science, the real joy of our scholarly activities with the public at large. And that's why I urge you and encourage you to develop the skills to communicate the scholarly activities that you and I enjoy to others in society.
Let's have one more round of a virtual applause for all of today's amazing speakers. Okay, and now what we have all been waiting for, we are incredibly pleased to announce the winners of the University of Wisconsin-Madison's 7th 3rd-minute thesis competition and first ever virtual competition. The winner of the People's Choice Award as voted by you and the audience and taking home a $250 cash prize is Lauren Bagwell with her talk, Art as Discussion, Engaging with Social Issues in the Classroom.
In 3rd place, taking home a $250 prize, is Katie Zarbach with her talk titled, What Your Gut Reaction to Alzheimer's Disease Research, Intersections of the Gut Microbiome and Alzheimer's Disease. Congratulations, Katie.
Next, in 2nd place, taking home a $450 prize, the winner is Olivia Harward with her talk titled, Can Immunotherapy Cure HIV? Congrats, Olivia.
And finally, we come to our 1st place winner in the 2021 UW-Madison Virtual 3MT competition. The winner will be taking home a $700 cash prize and representing UW-Madison at the Midwest Association of Graduate Schools Regional 3MT competition. The winner is Claudia Ramley with her talk titled, Can Nonverbal Feedback Help Students Learn? Congratulations, Claudia.
Congrats, Claudia. Would you like to say a few words?
Sure, yes, thank you. I am very, very honored and very grateful to receive this award. Participating in this 3MT competition has taught me so much about my research, its impact on the community, as well as the inspiring research of my fellow competitors here today. I just want to say a sincere thank you to the judges, the sponsors, to everyone who organized this event behind the scenes. And I also want to thank my advisor, Martina Rao, who supports me on my research journey, as well as my wonderful colleagues in the Learning Representations and Technology Lab. And finally, a thank you to my family, my friends who are watching, and to my husband, Edmund Ramley. They kept receiving so many versions of my 3MT presentation, and they were instrumental and very generous with their feedback. Again, it is truly an honor, and I look forward to representing UW-Madison regionally. Thank you.
Thank you, Claudia, and congratulations. We look forward to watching you compete at the Midwest Association of Graduate Schools regional competition in March. Well, that takes us to the end of our event.
Yes, it does. Congratulations again to all of our 3MT graduate students. Thank you again to our sponsors, judges, competitors, organizers, and especially our audience.
If you would like to learn more about the interesting and impactful research being done by University of Wisconsin-Madison graduate students, follow us on social media and check out the graduate school's 3-Minute Thesis webpage. We hope you enjoy the rest of your evening and have a wonderful week. Good night.
Good night.